Hi there, I'm Dimitris Karalabidis, and in this video, we'll work together on what we call slope-intercept form of a line. Before we even begin, let me remind you of one simple thing, that a line can be presented in four different forms. First of all, we have the slope-intercept form, slope-intercept form. Secondly, we have what we call standard form. Thirdly, we have general form. And finally, we have what we call point slope form. On this video, we'll focus entirely on that, on the slope intercept form. And this video will be split in two parts. At first, I'll show you what the slope intercept form really is, why we called it like this, why we actually called it slope and intercept form, how we can determine the slope and the y-intercept from a slope intercept form, and on the second part, we'll see together how we can actually determine the equation of a line in slope intercept form. So let's begin on the first part. The slope intercept form of a line is the form y equals mx plus c. So anything we see that looks like that, something times x plus something else, is representing a line, and that specific form is called slope-intercept form. Remember that m and c can be any numbers. Some of you have learned it as mx plus b. I learned it in your age as ax plus b, but still is the same format. Something times x plus something else. Now, why did we actually call it slope-intercept form? Because this here, sorry, because this here is the line's slope, and this here is the line's y-intercept. So this means that the coefficient of x shows the line's slope, or in simple words, the line's direction, while the c, the constant number we have at the back, shows the line's y-intercept, which is the point where the graph of a line intersects with the y-axis. So far we have this first skill. Skill number one, make sure that you are able to recognize a line's slope and y-intercept. Let's see some examples. Example number one, y equals 3x plus 1. This is given directly in the form something times x plus something else. So this is the slope, and this is the y-intercept, which means that in this case, the slope is 3 and the y-intercept is 1. Second example, but still similar. Y equals negative 5x plus root of 3. Again, this is written in the form something times x, so that would be the slope, and the constant number at the back should be the y-intercept. So in this case, slope is negative 5, the y-intercept is root of 3. A third example, y equals 3x. We can clearly see that this is the slope because it's the coefficient of x, but we don't see any constant at the end. Does that mean that the line does not have a y-intercept? Because we know, or we should know at least, that not every single line has a y-intercept. But the lines that do not have a y-intercept are the ones that have an undefined slope. This is not the case, however, because we can see that the line's slope is 3, so there should be a y-intercept. So where is it exactly? Well, you can think that 3x, it's the same as 3x plus 0. But simply because it was plus 0 and it wouldn't affect anything, we skipped it. But still, this is the slope, and that would be the y-intercept. So in that case, which is a special case, slope is 3 and the y-intercept is 0. Let's see a fourth case, y equals 10. Well, this is something new. We don't have any x. So this means that we don't have any slope. So that would mean that the line has an undefined slope. Not exactly. All you have to do is to simply think that 10 is the same as 0x plus 10. The only reason we skipped that was because 0 times x, it's still 0, and 0 has no influence on any addition or subtraction. So here, we would say that the slope is 0, so slope is 0, and the y-intercept is 10. Y-intercept is 10. Fifth, y equals 4x plus 1 over 2. Remember, some of you are tricked and simply say that the coefficient of x is the slope. That's not entirely true. This is only true when the given line is given in the slope intercept form, only in that form. And that is something that you should bear in mind from now and on, because we will see standard form, we will also talk about general form, we will also see the point slope form. Please try not to do this mistake. Do not just say that the coefficient, the number in front of x, is the slope. This is only true in the slope intercept form. And what we are now given is not in this form, simply because we have 4x plus 1 over 2. So what should I do in this specific one? I will try to rewrite it first in the slope intercept form. How is that done? I will split the fraction into two different ones. 4x over 2 plus 1 over 2. 4x over 2 is the same as 2x. 1 over 2 is just 1 over 2. Now, however, I managed to re-express it in slope-intercept form, which means that now we have the slope being number 2. This is the slope. And then we have the y-intercept being 1/2. And finally, a very, 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 very special case, which is the line x equals something. Let's say it here, x equals 7. Here, we see that we do not have any y at all. We should know, or at least it's time for us to know it, that when we say x equals 7, this is the x-axis and this is the y-axis, x equals 7 is a line which is perpendicular to the x-axis and simply passes from the x-coordinate of 7. In this specific line, we say that the slope is undefined, we don't have any slope, and the y-intercept simply is not there. We don't have any y-intercept. But this is something special. For now, I just want you to know the basics. Y equals something x plus something different. You should know that the coefficient of x is the slope and the constant is the y-intercept. And of course, be able to manipulate some strange cases like y equals 5x or y equals 10 or the fifth case of a fraction. That was with part A. We said that one of the skills that we need to develop is to see if we can manage to be able to determine the slope and the y-intercept. Now, it's time for us to learn how to find the the slope intercept form of a line on our own. Before we do that, however, we need to acknowledge the following, that in order to uniquely identify a line, I need either exactly 2 points of the line For instance, this, if I have 2 points AB, all of us would draw the same line. So we have discussed that again. If we just have 2 points, we can easily determine one unique line. So if we have 2 points, that's enough. Or secondly, if we have 1 point of the line plus the line's slope, which remember, we have said that the slope plays the same role as the line's direction. So if I know that my line is passing through point A and has a direction towards this house here, then I would still be drawing one unique line. Now, this means that every single time you are asked to find the equation of a line, whether that is in any form, slope intercept, general, standard, point slope, you should start from this very own concept. I just need 2 points of the line or 1 point with the line slope. Now, let's work together an example with 2 given points. For example, let's assume that the line we are looking for passes through the points 2, 5 and B 5, 11. I am looking to find the slope intercept form of this line. But I just saw that the slope intercept form is a form that looks like y equals mx plus c, where m is the slope and y is the y-intercept. Let's begin with the slope, because we know that for the slope, we have a slope formula. And if you remember that already, it's y2 minus y1 over x2 minus x1. By assuming that point A is x1, y1, and point B is x2, y2, I can easily find that this slope formula is now written as 11 minus 5 over 5 minus 2, which is 6 over 3, which is 2. So I just found that the slope is equal to 2, which means that my line so far can be rewritten as 2x plus c. Now, the only missing parameter is the value of c. How can I find it? What else have we learned so far? We spoke about slope. We used it. We used the slope in the slope formula. Then we talked about point of a line, and we saw some specific cases of points, which were the intercepts. We know that for the y-intercept, we should put x equals 0. But this here wouldn't help because we don't just want to determine the y-intercept. We want to find the value of c. What else do I know, however? I know the general concept of a point of a line, which is what I keep calling as poem. We know that point A lies on the graph of this line. So this means only one thing, that the coordinates of A, which are 2, 5, if properly substituted, and by this I mean if x equals 2 and y equals 5 in the lines equation, they will produce a true statement. So y equals 2x plus c. I'm going to put 2 instead of x, 5 instead of y. So 5 equals 2 times 2 plus c. 5 equals 4 plus c. So c is 5 minus 4. C is 1. I was able to find the value of c as well, and I'm done. I can easily say that the slope intercept form I was looking for is the form y equals 2x plus 1. I'm going to leave this on the left half of the screen, and I'm going to create a quick methodology. We always begin by just writing y equals mx plus c. Remember that if we make it and we find the values of m and c, we'll be done. The question will be over. We begin with finding the value of m, which is the slope, and for which we have a specific formula. Y is y2 minus y1 over x2 minus x1. And then for c, we substitute the coordinates of any point. A question you often do in class is, do we have to choose a specific point? No. Any point will do the work exactly the same way. If you use point A and you find a specific value of C, but you use point B and you find a different value of C, then I'm sorry to inform you, but you have done something wrong. It shouldn't be that case. You should be able to find the same value of C whether you choose point A, point B, or any other point that lies on that line. So always begin by the slope-intercept form, find the slope first, and then the value of C based on the coordinates of any of the points. Let's do some examples for practice. Let's find the slope-intercept form of the line that passes through A, -1, 3, and B, 4, 17. You can either freeze or pause or take 1 or 2 minutes, and then I will solve it with you as well. Let's solve it then. Like I said, y equals mx plus c. We always begin with that. And then we just need to find the values of m and the values of c. How will I start? Always from the value of m, which is a slope and for which we have a specific formula. y2 minus y1 over x2 minus x1. Here, we should always assume that the coordinates of one of the points is x1, y1, and the others are x2, y2. In this case, it should be 17 minus 3 over 4 minus minus 1. Please be extra careful with the signs. 17 minus 3 is 14. 4 minus minus, it's 4 plus 1, 14 over 5. Okay, it's not an ideal number, it's not a whole number, but it's still a number. We shouldn't be afraid of fractions. So far, we know that instead of y equals mx plus c, I can equivalently write it as 14 over 5 x plus c. What about the value of c? Just use the coordinates of any of the points. You can use point A or point B, the coordinates of point A or the coordinates of point B. Let's use here, let's use A because it has smaller numbers, only for that. A has the coordinates of -1 and 13. This means that this is x and this is y, which means that I'll go on the equation I have found already, y equals 14 over 5x plus c, and instead of x, I'll put -1, instead of y, I'll put 13, and then I'll do the calculations. This creates the 13 equals 14 over 5 times -1 plus c. 13 equals negative 14 over 5 plus c. 13 plus 14 over 5 equals c. Now I will just need to rewrite them. 13 times 5 is 65 over 5 plus 14 over 5 is c, which means that in the end it's 79 over 5 equals c. I made it. I wanted to find the slope-intercept form, and that's exactly what I did. Y equals 14 over 5x plus 79 over 5. That is the slope-intercept form of the line that passes through those specific points. Let's do another example. Still for practice, I want you to see how safe it is for us, for you, to follow this specific methodology. Let's try to make things a bit harder. B is 2, -5. So, again, I am looking for the slope-intercept form, which is the form y equals mx plus c. M is the slope and c is the y-intercept. I'll begin with the slope. M. M is y2 minus y1 over x2 minus x1, which means -5 minus -3 over -2 minus -1. So that is equal to -5 plus 3 over -2 plus 1. That is -2 over -1. That is equal to 2, which means that up to here, instead of y equals mx plus c, I can write y equals 2x plus c. Now, in order to find c, I should use the coordinates of any of these 2 points, either A or B. It's totally up to you. I would say here, if I was afraid of signs, that it might be easier to use point B. But if you are not, here I'm going to do it by using both A and B. It's totally up to you. Let's use the coordinates of A first. -1, -3. That should be x, that should be y, and the y equals 2x plus c will become -3 is 2 times -1 plus c. -3 is -2 plus c. So -3 plus 2 is c. C is -1. Let's now use the coordinates of b, 2 and -5. X should be 2, y should be -5. So the y equals 2x plus c will now turn into -5 is 2 times 2 plus c. Hold on. Did I do any mistake here? It's 2 times -1, it's -2, -3, -1. Let me see something. It's -5 minus -3 plus -2. That was the mistake. You see here, how did I understand that something went wrong? I did these operations here, and I found that I'm basically finding different values of C. This should not be the case. What did I do wrong? What I did wrong was here, that sign. It was never -2. It was just 2. So 2 plus 1, so that would have been 3, which means that the slope would have been -2/3. Let me rewrite them then. It's okay. It's a good thing that we saw that in action because this shows how careful you should be while working. The slope is -2/3, and then it's the point to a -5. If I now use point A, that should become -3 is -2/3 times -1 plus C, 2/3 plus C. So -3 minus 2/3 is C. Minus 9/3 minus 2/3 is C, which means that C should be -11/3. Let's see if this time things went right and we managed to find the same value of C, because this is the only indicator that something might have been wrong. -5 is -2/3 times 2 plus C. -5 is -4/3 plus C. So -5 plus 4/3 equals C. -15/3 plus 4/3 is C. So finally C should be -11/3. And yes, we did it this time. We were all right. So final answer would be that the slope-intercept form of the line that passes through these two specific points, A and B, would be the form y is -2/3 x minus 11/3. And now let's do one final example, still on the same concept. I said before that in order to uniquely determine the equation of a line, you can do it in two different ways. First way is if you know two specific points of that line, and we just work 3 examples on that. The second method, the second pathway would be if we just know only one point, but we also know the line's direction. So this line's direction here would be represented by the slope. Let's work an example in which we want to find the slope-intercept form of the line when we know that this line passes through the point -1, 3 and has a slope of 3. However, the concept, the methodology, the process will still remain untouched. What would that be? That I'll begin with the slope-intercept form. The slope-intercept form is always a form like this, y equals mx plus c. And on every single line, we should be looking to find the value of m and the value of c. Here, the value of m is the slope, and that would be the y-intercept. Normally, before, we would apply the slope-intercept form because we were just given 2 points and we had to find the slope. Here, however, what has it changed? The slope was given directly to us. We were told that the slope should be 3. So here, we know that m is 3 because that was given. So no need to actually use any formula because we were told directly that the value of slope in this case is 3, which means that my form y equals mx plus c can just be written as y equals 3x plus c. Still, however, in order to find the value of c, I should apply what I did before. What was that? I would take any point I wanted and plug in its coordinates properly and carefully, like we saw before. Here, I'm not given the option to choose. I only have 1 point, so I have to use its coordinates. Here, the point was negative 1, 3. This is x, this is y. So 3 is 3 times negative 1 plus c. 3 is negative 3 plus c. 3 plus 3 is c. So c is 6. Which means that in the very end, we have the slope-intercept form of 3x plus 6. So that one is the same as before, but even quicker. Why is that? Because we have eliminated the part where we are actually using the slope-intercept form to determine the slope. Let's do another quick example and we'll wrap up everything. Find slope-intercept form of the line that has a slope of negative 3 and passes through the point A with coordinates negative 2 and 1/2. It can be anything. We are not afraid of numbers. Any number given, we will just apply the same process. Here, simply because we were told to find the slope-intercept form, we know that we are looking for such a form. Then, this is the slope, but the slope was given as negative 3. So this means that y can be written as negative 3x plus c. How can I find the value of c? I will now use the coordinates of that point. What does that mean? That I will go to the equation of the line that I have. Instead of x, I'll place the point's x coordinate. Instead of y, I'll put the point's y coordinate respectively, 1/2. And simply because of the poem that states again that this point lies on a line because its coordinates, when substituted, they will create a true statement. So I know that if I do this substitution, 1/2 equals negative 3 times negative 2 plus c, this is true. So 1/2 is 6 plus c. This is also true. So 1/2 minus 6 is c is also true. But this is the same as 1/2 minus 12 over 2 is c. So finally c is minus 11 over 2, which means that the line I was looking for has, an equation of negative 3x minus 11 over 2. And that would be all. What have we learned today? We talked about the slope-intercept form, y equals mx plus c. We need from now on to recognize that whenever we see something like that, this graphically represents a line. We should be able to identify directly the slope, directly the y-intercept, and then we should be able to repeat all this process when given either 2 points or 1 point and the line's slope to produce by ourselves the equation of that line. That would be all. I advise you to watch over again and again and again, as many times as needed, this video. If you have any questions and you are already one of my students, please send me an email for further explanations. If not, don't be shy, we're all friends here. Leave me your question in the section below. As always, thank you for watching.